that we need to talk about is this thing that apparently, like, Connie didn't do a good job, or you guys weren't paying attention, or Arjun was standing in the way. This is the worst excuse I've ever heard. Apparently, a bunch of you didn't get it, so we need to do this. It only takes about 10 minutes. So could you take out your proof of the sum of the cubes, which I think I asked you to do in a separate sheet of paper, but never collected because we just kept running out of time.
Yeah.
Do you guys know what I'm talking about? And we're just gonna like do it right now. Do you know what I'm talking about?
Yeah.
You're looking despondent. Yeah. So the goal, this thing, and some of you were like successful, in which case I'm sorry, you're just gonna be bored for the next 10 minutes. Ethan, is that all right? Just smile and look pretty for the camera. You're in the direct line.
You are, Ethan, it's true.
All right. So the goal of this was to figure out a formula for the sum from I equals 1 to n of I cubed. So this is just like 1 plus 8 plus 27 plus all the way up to n cubed. And what I would like to have is a nice formula for this. Raise your hand, just out of curiosity, raise your hand if you totally understood the lecture by Connie, it was perfectly chill, you went home, you did this, you got the right answer, and you're just like 100% set.
What if like half of those are true?
Yeah. We allow for them.
Okay, so it's really only like 4 people. So, okay, so this is just, so then I guess this is worth doing, so we can do it right now. So here's the goal, let's figure this out. And so let's do it. Background knowledge, background knowledge is that you already know the other formulas. So we already know that the sum from I equals 1 to n of I, otherwise known as 1 plus 2 plus 3 plus all the way up to n, is, what is that? N times n plus 1 over 2. And the other part of the background knowledge is what you actually discovered in that original lesson when I wasn't here, which is the sum of the squares, which is 1 plus 4 plus 9 plus. Okay, and if you didn't understand it, then you can just like go back and like figure it out now based on what we're doing. But anyway, we did the whole thing with Connie, we ended up with the magic formula, which is
n plus 1 times 2 plus 1 over 6.
yeah. So, assuming that you know those things already, then we will do this thing. So it's kind of like recursive, right? Like once you get one formula, then you can like move on to the next one. Okay, so the background, alright, so we're just going to begin. And the first couple steps, if you haven't ever seen this before, which you guys have, then the first couple steps are just bizarre. You don't see where this is going, but then suddenly it all comes together. So, if I would like to know the sum of the cubes, I'm actually going to take the difference in the fourth power between a number and the number less than it. So, this is what you were supposed to do for homework, is like this, right? You just have to take like a number to the fourth power minus the fourth power less than it. Okay, so you just like do a little bit of algebra basically, and if you can just like quickly do this now while I'm talking, if you have not already, you should just like quickly do this now. But what you're going to end up with is 4a cubed minus 6a squared, I'm just doing this from memory, plus 4a minus 1. Is that right? Yeah. Okay. So, now that you have that happy little formula, you can do this thing in which you say, all right, well let's write an equation. Let's write the equation n cubed minus n minus 1 cubed. Well, what is that? Well, I just did this a second ago, right? It's just like that, except a is n. So it's 4 n cubed minus 6n squared plus 4n minus 1. Okay, great. And now, just beneath that line, you write a new line where every number now goes down by 1.
Using the
Wait,
power
it should
up.
be end of the fourth.
Oh man.
Using the power on the left.
Yeah, you did.
Yeah.
You did.
Okay, it should be
Oh yeah. Embarrassing. Good thing no one's taping this. Alright, then over here we have n minus 1 to the fourth minus n minus 2 to the fourth. Okay, well what will that be? It's like the same pattern, right? It is still a number to the fourth power minus the fourth power less. So I'm still going to use this kind of general setup, but now a is just n minus 1, right? So now over here I write 4 n minus 1 cubed minus 6 n minus 1 squared plus 4 n minus 1 minus 1. Makes sense, everybody? Of course it does. Okay, just keep going. So n, what's n minus 2 to the 4th minus n minus 3 to the 4th? Well, it's still the difference between a 4th power and the 4th power less, so it's still just this general pattern, but now the number is, a is n minus 2. So it's 4 n minus 2 cubed minus 6 n minus 2 squared plus 4 n minus 2 minus 1. Okay, etc., etc., etc. And you just keep on doing this, basically, until we get down to 2 to the 4th minus 1 to the 4th, which, well, what's that going to be? What's a now, Shire? What? What's a now, class?
2.
A is just 2 now, right? Same thing, but now a is just 2. So this is just like 4, 2 cubed minus 6, 2 squared plus 4, 2 minus 1. And these are all just kind of like dot, 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 dot. And then the last equation will be when I have 1 to the 4th minus 0 to the 4th. And what's that? Second try. What's a now?
1.
1, yeah. So this is 4, 1 cubed minus 6, 1 squared plus 4, 1 minus 1. Okay, so this is all just a bunch of mindless stuff, which is, if this is the first time you're ever seeing this, you just have no idea where this is going or why we're doing this. But before we get to the dramatic conclusion, just this like note, like how many equations do I have here? A lot, right? Let's see, I have 1, 2, and I call it n equations, right? Okay, so I have n equations, and now we add them all up. And something dramatic and awesome happens on the left-hand side, because you have n to the 4th minus n minus 1 to the 4th, plus n minus 1 to the 4th, minus n minus 2 to the 4th, plus n minus 2 to the 4th, minus drup, 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 drup. So everything just on the whole left side just becomes, alright, and we get n to the 4th.
Thank you.
Yeah. This collapses. There's a term for this in mathematics. This is called a telescoping sum. Did Connie talk about this?
No.
A telescoping sum is one where you add up a bunch of things and like it all like kind of cancels each other out and you end up with just one thing. You guys know why it's called telescoping?
So when you collapse the telescope, it becomes one.
Wait, so she did talk about this or you just know stuff?
It just makes sense.
Obviously, that's
Just good. Dee says it's obvious, so if you didn't get it, she's just called you dumb, I think. Yeah, because like old-fashioned telescopes look like this, you know?
Yeah, actually,
Yeah. And so when you have the telescope, then you just like, you know, whoosh, and then, good. Okay, so anyway, then what's happening now? It's 4 times 1 cubed plus 4 times 2 cubed plus 4 times 3 cubed plus 4 times 4 cubed, all the way up to 4 plus n cubed. But what's that? When you add them all up, it's just 4 times the sum of the cubes. In other words, the sum of all the terms in that column is 4 times the thing which I'm looking for. And then what?
So the sum of cubes is n4 over 4, if we're doing the math.
What are you talking about? Hold on, I'm moving on. Minus, no, I didn't hear you slash, I don't understand what you said. So this is 6 times 1 squared minus 6 times 2 squared minus 6 times 3 squared all the way up to there. So that's minus 6 times the sum of the squares, right?
Yeah.
And then this is 4 times 1 plus 4 times 2 plus 4 times 3 plus 4 times all the way up to 4%. So this is plus 4 times the sum from I equals 1 to n of I. And then this part is where people mess up for some reason. Minus 1, minus 1, minus 1, minus 1. How many of those? N. So this is minus n. Okay, so when I add up all of these n equations, the left telescopes and the right neatly condenses into the like sums of various things. Now the whole thing, yeah, I already know what this is, and I already know what this is, otherwise I shouldn't have attempted this problem. And so there's only one thing I don't know in this formula, and that's this thing, the thing that I want. So do you guys get this now? It all just kind of turns into a little algebra problem. This is n to the fourth equals 4 times, let's just call this x, because this is the thing I'm interested in. Well, actually, let's not do that. So I cubed minus 6 times, I already know the formula for the sum of the squares. It's n plus 1, 2n plus 1 over 6. And I already know the formula for the sum of the i's. It's n plus 1 over 2, and then this is just minus n. Does everyone kind of get this now, if you didn't before? Should we just like finish it right now while we're at it?
Yeah.
Yes, some things cancel. Griffin, can you like left justify me to like that line? And then so we get some cancel, we get some this, and so I actually end up with that 4 times the sum of the cubes is, moving all those other things over, n to the fourth plus n plus 1, 2n plus 1, minus n plus 1 plus n. I think I did that right.
Wait, this would be like a 2.
Oh yeah, there's a 2 there, so I didn't do it right. Okay, and then continuing to simplify this, although I'm kind of just like doing all the work for you now, I guess I could take out an n at least from everything, right?
Yeah.
So let's just do that maybe, like straight off the bat. But otherwise, I guess I just have to multiply stuff out. So this is n cubed plus, I took out the n already, so that's 2n squared plus 3n plus 1. Took out the n, so it's minus 2n minus 2, which is like plus 1. Make sure I didn't mess that up. I think it's right. I hope it's right. Plus 1 plus 1 minus 2, so the 2's die. So
Another n?
I think I can in just a second. So this is n cubed plus 2n squared. That's just like plus n, right?
Yeah.
Yeah. So I can take out another n. So yeah, so that's n squared plus 2n. Am I going too fast, or are we cool?
Cool.
I think we're cool. So this is n squared, n plus 1 squared. So the sum of the cubes is quite dramatically, and very beautiful formula, n squared, n plus 1 squared over 4. Okay, do you guys get this now? Like you could reproduce this later if you needed to. And by the way, if you didn't get the other proof, you should like go back and do that. Anyone notice anything kind of awesome about this? Yes, everybody. Say it all, talk at once.
It's
Wait,
the
that was
n,
where
the
the
1
formula
to
for the
n.
numbers.
Yes, this is actually the square of the formula from I equals 1 to n of just like I, right?
Yeah, that makes sense.
So that makes sense, really?
No.
Claire, it doesn't make sense at all.
Doesn't make sense.
So this is kind of like exciting, and we're going to talk about that a little bit more later. All right, good. Get it? Can you hit the off button because we're going to stop one thing there.